Okay, to get started, I would recommend that you go to the video description of this video and go grab the GitHub project README file link. And that allows us to walk through this together. I generally design it for us to be like a walkthrough. Okay, so this is video 2 of the Simple Container series. It's the Azure Simple Containers in Azure. And we're going to take a Python-based microservice and deploy it as an Azure Container App. This video complements the Azure VM Scale Sketch video, and in that video we deployed these very simple Flask microservices on VMs, and then we did a scale set to manage the VMs. And essentially what the way it was configured is if it was greater than 60% average CPU across all the servers, it would add VMs up to 4, and then if it was below 60% for 5 minutes or more, it would remove instances, and it would flex between 2 instances and 4 instances. So that's how the scaling would work. And so what we're going to do is we're going to take that exact same microservice code, we're going to build it into a Docker container, push that Docker container into a container registry, and then deploy it using Azure Container Apps. And so what we'll cover is we're going to deploy Azure Cosmos DB like we did with the scale set video. Same deployment there. Then we're going to containerize that same Python microservice using Docker. We're going to deploy an Azure Container Registry instance, push that Docker container that we built into the container registry, and then finally deploy the Azure Container App using that instance that we built, or that container image that we've built. So let's talk about the components, the Azure components we'll be using. The first one is the Azure Container Registry. And all these service providers, the cloud providers, have almost the same sort of services regarding container registry. And I think that's more of a function of the fact that they didn't invent this technology. Essentially, Docker many years ago published I think it's about a decade ago, published the interfaces for a container app or a container registry, and Azure, AWS, and Google went and implemented that contract API. There's not a lot of secret sauce associated with it. There's differences around the margins as far as how you authenticate, cost, pricing, that sort of thing, geo-replication, but they all pretty much functionally work the same. And so you can also use this with other ecosystems. So there's ability to have like a public registry, Docker registry, and it can be used in other ecosystems. Like you could use it maybe within like Google Kubernetes, but I'm not sure many people do that. Usually if you're using the Azure Container Registry, you're within the Azure ecosystem. And so that's it for the container registry. The next thing is the Container App. And this was introduced by Azure in 2021. Kubernetes came along first, but Kubernetes has this sort of built-in complexity. This is sort of baby steps to Kubernetes. It allows you to, build a container registry, put in a Docker file or Docker build, and then you can just pull up and say, go run that Docker build with minimal configuration, and it handles it sort of like almost like a VM image. It just goes ahead and deploys it. You give it what port, you give it security, and it just handles it. I think a lot of this is, like I said, baby steps to Kubernetes. And professionally, whenever I'm deploying a container app, it almost always gets into Kubernetes. I've seen some ECS, but I've never seen one really used with these simple container app strategies. But like I said, they're baby steps. It allows you to do some unit testing to eliminate a bottleneck. So if there's a problem with the registry, you can just very simply go in and manage these. And so what we're going to be building here in the U.S. Central region is we're going to build a ACR instance for the Flask app. When we build that, that's the first part of the build. The second part of the build is we're going to build this Flask app Docker image, push it into the container registry. And then finally, the third stage, we're going to create a container app. It's going to pull the registries from the Flask app container registry, and it's going to interact with the Cosmos DB database. Now, it was sort of a challenge here with the roles. that you have to assign. And the issue that I had was when I used the system identity for the container app, I didn't have it to set the role to actually do ACR pull. And so what I ended up having to do, there was several solutions that I saw out there. One of them is you build with like a BusyBox or Nginx container that's public, and then you get the system identity, and then you do that. But what I ended up doing is I create a user identity, a managed identity for the container app before I build the container app, and then I assign the roles appropriate to access Cosmos DB and the container registry. And that way I can do it all up front. Then the container app, when it runs, can actually do the ACR pull to container registry. So we'll see that when we get the prerequisites, where there's a certain set of permissions that you need to set. And I guess that's a good point to get the prerequisites. The prerequisites, you need an Azure account, you need an AZ CLI, you need the latest Terraform. We're going to use Postman for testing. You need to install Docker to build Docker locally. Then these are some new areas specific to this project. You need that Microsoft.app provider. It must be enabled. I do enable that in the check-env script. This sort of has shades of the API management that Google provides, but it is a Microsoft thing of providers. And then finally, because of that whole role thing that I described up here, you're going to have to make sure that you have the user access administrator role assigned to the build identity. Now, if this is the first time you're watching our content, you might want to start with this video, which is Azure plus Terraform Easy Setup. It just gives you a very simple project that deploys a single VM, so you can check that your account and everything is set up and is good to go. And the only other thing that I was going to do is take a quick detour and show you where this is in the user interface. The User Access Administrator. So if you go and do Home and do Subscriptions, and then click on your subscription and go to IAM Access Controls, and you can see role assignments. You can see that I have in here I have the User Access Administrator. This is the UI that you go in and you do add, but the check-env script actually makes sure that it's there, but you may get an error when you run check-env, in which case this is where you would add it in the console. So let's go back to the script here, and let's go to download the repository code. So I'm going to copy this here, and then I'm going to go to my Ubuntu environment, paste that in, and I can see I'm in there. What I'm going to do is I'm going to run check-env, and it's going to go through and make sure you have all the different environment variables you need to be set. Again, look at that original video of easy setup. It's going to register. It's going to make sure Microsoft App is currently registered, or that it's registered, and if not, it'll register it. And then it also checks to make sure you have the user access role. So at this point, what we can do is we can go and run the apply. And while let's do that, we'll talk about roughly the 3 stages of the build. Okay, so the build consists of 3 distinct phases. The first phase is we build the Azure Container Registry ACR instance, and we use that in Terraform. Now, one of the things that we'll get into on the differences is when you create the container registry name, you have to pick a name that's unique across the entire Azure namespace for their domain that they use for it. So you have to supply the uniqueness of your repository name. The other providers, AWS uses your account number to generate uniqueness, and GCP uses I guess the project ID to guarantee uniqueness. You are responsible for it. So once we do that, we're going to run the Docker build and push. The Docker build is going to build that Flask microservices using an Ubuntu image, and then it's going to push the results into the ACR repository. And then the final part is we're going to deploy an Azure Container App where we glue this all together. It instantiates an instance of the image that we pushed into the container registry, and stands up. You specify the runtime parameters, and then you're off to the races. And then at the end of all this build, we run a validation script. So let's go to the build, and you can see the Cosmos DB account takes quite a bit of time. So we're just going to pause here and let it finish. Okay, so the build has completed. I actually had to run it again because I cleared, but it's completed. And essentially, one of the things you'll notice is it takes a while for this API to become available. In AWS, when you do an app runner, it's the Terraform is synchronous to the deployment. So when the Terraform's done, you're deployed. With Azure and GCP, the deployment of your container is asynchronous to the Terraform. So you have to sit there and wait to make sure it's working or available after the build, which is a minor thing, but when you're trying to script all this together, you do have to take that into mind. So the first thing we're going to do is we're going to grab this good to go URL and do some simple smoke testing. I'm going to go over here, and I've already done it, but I'll do it again, and you can see it's running. So the build succeeded, and now what we're going to do is we're going to walk through the Azure console. So the first thing you want to do is go to your resource groups, because everything's a resource group in Azure. So let's click on the Flask Container resource group, and you can see all the components that got built from the project. The first one is the Container Registry, the Flask app EE4DE2. Now this goes to you are responsible for guaranteeing the uniqueness across all Azure clients. So you can see it uses Azure CR.io. You're responsible for that part, and there better not be a conflict. So what I did here is I just used part of my subscription ID. You can do random numbers, but whatever, you have to guarantee that this name is global across the Azure namespace. You don't have to do that with the other cloud providers. They do it for you. AWS uses the account ID as the identifier, and then GCP uses the project ID as the unique identifier. So you got to manage those collisions yourself. So then let's go to repositories, and you will see we have the Flask app, and there's the Flask app. One, you click on it, it gives you sort of the standard attributes associated, Docker pull. So it's all following the Docker interfaces. So let's go back over here, and that's pretty much it for the repository. It's very simple. They're all pretty much the same, except for minor differences between the different providers. So let's go back to the resource group. And we've got the candidates table in here. And then we've got the managed identity, which is we use that to assign to the Flask Container App. And then we assign roles to the Flask Container Registry and the candidates table that allows that user identity associated with Flask Container App to access do the ACR pull and access the table. So let's look at the Container App. And then the Container App, let's go to revision. It has the URL that we've been accessing, the revisions and replicas. You see you've got instance running. This is where it's really nice for debugging purposes, where you want to go see the logs. In Kubernetes, these logs are just everywhere. If you don't have Grafana or something else installed to collect the logs, it's rooting around in a dumpster is how I often describe it. And so I can go say, okay, give me the log stream for the container, and it goes and it gets the startup container. It also has the logs from the orchestration part of it, and then you can show that it's got 1 to 3 replicas. Its default, it's going to scale up based on HTTP load, and again, it gives a unique name. So it's fairly simple. There's a scaling rule. One thing that's unique is it uses KEDA, Kubernetes Event Driven Architecture, which allows you to do much more extensive. Like I can add much more much more subtle rules than the other providers. And I think that's because it's actually using Kubernetes on the back end. It's just a guess, but just everything that I've seen suggests that. Probably the other ones are too, but here it's like very obvious because they're exposing the Kubernetes scaling mechanisms as the default scaling mechanisms. So that's pretty much it for the container app. What we're going to do now is we are going to test this in Postman. Alright, so we're going to go back to the where we built the project and run validate again, and it's going to give me the good to go endpoint. So I'm going to take that and I'm going to copy that and I'm bring up Postman and say, all right, let's go to good to go. And you say it worked. That's the first endpoint. The next one is candidates, and you can see there's only John Smith. Then there's a candidate endpoint, which is a get. I'm going to say John %20 Smith, and it's going to show me that. And then there's a post. This is the fourth endpoint, and I'm going to say homie, and I'm going to send that. It's going to give me homie. Now if I go back to get, you will see, and I do candidates, you can see I got both of them. So those are the 4 endpoints that proves that it actually works. And so what I'm going to do now is, I think I'm at the point where I'm going to destroy it, but let me make sure I haven't missed anything. So we're going to destroy it. And so I'm going to go to be a good steward of our cloud accounts, and I'm going to do destroy sh. So now let's talk about the Azure specific issues. The first one, we've covered the container registry URL uniqueness. You're responsible for setting that up. We'll either use part of your subscription UUID or a random number. The other container registries don't require you to enforce uniqueness when you name it. You got the chicken and egg problem of ACR pull assignment on registry. If you use a system identity, when you create the container or the container app, you don't have the identity to grant the pull role, so it can't pull. So there's different strategies, and I ended up just doing a managed identity, and I use that as assigning a role instead of a system identity. We talked about the more robust scaling rules defined by KEDA. This suggests that AKS is used on the back end. Now, a lot of this stuff is just baby steps. Get to Kubernetes. I think professionally, if you're going to do a container app, you're going to end up using You're going to end up using Kubernetes. But this is sort of a baby step to allow you to get your stuff into a container registry, figure out the permissions and how that works, and then you can just spin one up quickly to make sure that it's working end to end. At that point, then you probably graduate to Kubernetes and you're building a bunch of YAMLs or Helm or whatever your Kubernetes strategy is. But this is sort of like a baby step to get there. And finally, the container app deployment is asynchronous to Terraform, which means if you run a build and it's done, it's not really deployed yet. AWS, it actually, when your build is done, Terraform build, it's at deploy. So I think this is probably more in line on how it's supposed to work, because you're expressing the desired state in the Terraform, and it gets there eventually. So it's not a big deal. It's just something I noticed on GCP and Azure. You had to wait a couple minutes for your container app or Cloud Run instance to boot up. So I think that's it for this video. The other thing is I'm going to do an advertisement for the next series. The next series is, if you go look at the project and you look at GitHub, there is a setup of GitHub Actions. These basically follow the flow of the build sh files, the apply, check env, destroy, validate. These are GitHub Actions that we will configure in another video series. And you'll have to configure a remote state, you have to configure these environment variables, but we'll walk through all those different steps you need to do it. And at the end of the day, what you're going to get is actions here. And I've been working on it, and I've got, last time I did build, and you get a pipeline that walks through what we've talked about. You build the ACR instance, you build the Flask container, you build the container app, and then you validate the solution. So we'll walk through how you do all of that end to end in another series on Azure, AWS, and GCP.